He is confused. Now he is thinking that already money which was spent for that 112 lakhs that is routed to that amount. That is routed to that amount.
ಅದೇ ನಾನು ಹೇಳಿದೆ ಅವತ್ತು ಹೋಗಿ ಅವ್ರಿಗೆ ಕ್ಲಾರಿಫೈ ಮಾಡಬೇಕು, ಇಲ್ಲಾಂದ್ರೆ ಒಂದು ಅಫಿಷಿಯಲ್ ಆಗಿ ಪ್ರಿನ್ಸಿಪಲ್ ಹತ್ರ ನೋಟ್ ಹಾಕ್ಸ್ಕೊಂಡು ಮಾಡೋಣ. A very good morning to all the participants. I welcome you all for the day 2 of this short-term training program on drivers of Industry 4.0. So this program is sponsored by AICTE, and today we have Mr. Umang with us, who is the resource person. He will be delivering a talk on big data analytics. So I now request Mr. Aravind to kindly take over.
Hi, good morning. Can you all see my screen?
Yeah, I can see, sir. We can see.
Okay. So let me just begin with a small introduction. So, good morning. So on behalf of Speakit, we would like to welcome each one of you to today's session. Our vision at Speakit is to connect academia with the industry by bringing in industry experts to impart their knowledge. Our session for the day will be on big data analytics. The session will be delivered by Mr. Umang Sharma. He works for one of the big 4 consulting firms in consulting. Mr. Umang is a data scientist and an author of an upcoming book on artificial intelligence and deep learning. He is also an official speaker of Google's machine learning crash course in India, an open source contributor to Google Colab, and advises Fortune 500 clients on AI and machine learning solutions. Thank you, Umang, for accepting our invite. The duration of today's session will be 90 minutes, including the Q&A session. We request you all to please mute your mics to avoid interferences. You can type in your queries in the chat box and we will answer it during the Q&A session. At the end of the session, we request you all to kindly take a few minutes to rate the session, the link for which will be posted in the chat box. Once again, we thank you for your time and we believe that this session will be useful to you. Umang, you can take over.
Thank you, Arvind, for the introduction. Hello, everyone. Good morning. Hope you guys all are good and safe and doing good amidst the lockdown. Let's get started. Can you guys see my screen already?
Yeah, we can see, sir.
Awesome. All right. Good morning, everyone. Good morning once again. It's great to be with you. My name is Umang Sharma. I'm a data scientist. I'm an author. I've been working in the tech sector for a lot of years now. We'll be talking about how we can do the big data analytics with Industry 4.0. Even though this is a very IT concept, we'll try to make it very mechanical engineering, and we'll try to make it as close as industries to possible. And then, so the whole idea of this talk is to understand what is big data, then what is big data analytics, how big data analytics works, where exactly you could put it, where exactly big data analytics works in industry, what's the potential use cases, where, how can you put it, how can you learn it, etc., etc. All right, let's get started. First of all, let's see what Industry 4.2, right? We've been talking about Industry 4.0, and the whole theme of this particular talk, the particular session is, or the program is about Industry 4.0. Let's understand that first. Industry 1.0 was the time when mechanical streams, mechanized machines were made first. Steam engines, hand weaving looms, swing machines. These were the Industry 1.0, where exactly there was no power or anything. It was all human intervention, but the machines were very automatic. As in human power automatic. Like, for example, you are swinging a machine, so you have to do like this. There's a juice machine, that's also Industry 1.0. You are getting a juice with your hands out, that's Industry 1.0. Steam power, steam engines are Industry 1.0. weaving, looming, all these things were Industry 1.0. So no motors, but still some basic machines which were used by, which were made to run by human power only. Then Industry 2.0 came. This was the time when Henry Ford started mass producing his cars, the Model T Ford. That was the time when the cars were started producing in mass production. Assembly lines, the concept of assembly lines were made. Uh, Things were automated in the form of an assembly line. People were able to make so much money using mass production. Electrical energy came, things like electrical energy. So, with the power of electricity, people were able to, people were able to run their industries. So, electrical energy came, electrical engines came, electrical machines came, mass production assembly lines came. That was Industry 2.0. So the time when automation started happening, like literal automation using machines, mass production, assembly lines, and other parts of it. Like a worker used to stay, in front of assembly line, and he has one particular job throughout the day to do. If for 8 9 hours or 10 hours, whatever his shift was, he would have to do the same job. It wasn't easy for humans, but it was very automative for the businessmen and for the industry. It was very efficient. Okay. Then came Industry 3.0. What is Industry 3.0? This was the time of 80s and 90s actually, when actually computers and automation via computers started to come in pictures. So now industries are using power of computers, robotic arms, basic ERP solutions. ERP solutions are like SAP and all those things where their computers are taking care of all your data storing and everything. Automation via machines came, right? So automation, as in when I say automation, like literal automation using machines, robotic arms, automatic paintings, or painting, I mean paint jobs. When I say paintings, I mean paint job. That is, your car is getting painted by the robot. Your tires are getting put by the robot. These things were done in Industry 3.2. Electronics came into picture. So your electronics, your machines would run on electronics. They'll have chips. You can live monitor the happening of the machine. You can live monitor everything. Your data is coming live. That was Industry 3.0. Now, what we are discussing in this session, what we are going to do in this session is Industry 4.0, which is nothing. No, I'm not okay. I should not say it's nothing, but which I should say. Industry 4.0, as some people say, is the extension of Industry 3.0, and it's more about, definitely it uses computers, but now we talk about things such as Internet of Things, networks, smart factories, automatic machines, connected machines, etc., etc. So these are the next level of technology usage in industries. That's Industry 4.0. So cyber physical systems are nothing but physical systems which are connected via computer, they're connected via internet, and they're getting used that way. That's cyber physical systems. Okay, that's how the Industry 4.0 came, and this is what we'll be discussing in these sessions. Yesterday was an AI session, today was a big data analytics session, and this is again part of Industry 4.0, and this is how things are moving at right now. Okay, moving ahead, let's actually have a better look in terms of Industry 4.0 in terms of analytics. Okay, like, because we're talking about big data analytics, so I mean obviously I'll be explaining what is big data, what is big data analytics, but let's see another timeline of industries versions, depending on where exactly we were and where that time and where exactly we are right now. So let's talk about old world, right? When I say old world, it's really, really old. It's before the time the steam power engine was made. Okay. So old world was like no data analytics, obviously. There was nothing, was simple. There was no computers, there was no data. Old data was there, like that. Okay. Old data analytics was there that way. And the whole idea was that, let me put it this way. So whole data analytics was. Hmm? All right, sorry about that. Old data analytics, what was that? Industry 1.2 came. So what happened is that now steam engines came, fossil powers came, manpower, and all those things started to come. Now what happened is that Now, obviously, at still point of time, even though we have power engine, fossil fuels are there, but but there is no, again, there is no, computers are not there. Industry 1.0, if you see, then obviously industry 2.0 came, electricity invented, electricity machines invented, less human power, obviously. That was the start of industry 2.0. At that point of time, slight thing that started was documentation. Okay, documentation started. I mean, when I say documentation, documentation of machines, the way machines are working, the way, what do you say, the way machines are working, the standard operating procedures of machines were actually documented. So that was industry, that was happening after when industry 2.0 was getting started. Okay. Then come industry 3.2, the green part of it. Transistors were invented, computers were invented. As I said, industry 3.0 was the starting of the usage of computers. That's when the actual automation started using computers. At that time, we got something called hard disk, which is a primary storage. And then again, the hard disk storage is invented. Now we can store data. Now we can access data easily. There is a fast access to data. Now we have computers to read data. So 3.0 is where exactly the root, the base of analytics started. Okay. The software tools were invented. So SAP we hear a lot, right? SAP actually started as an analytics tool as well. Even though it's an ERP tool, it's actually helped in analytics as well to few companies. After 3.0, obviously the things have taken a great speed. The whole world is running behind technology right now. So machine learning and AI came, smart systems came, zero human power started coming in picture. Now the time of big data analytics come. Now that we have great data, we have computers, we have hard disks, we have insane number of human computer power, etc., etc. So big data analytics started come into picture. And when I say big data analytics, cloud start to come, social networking, analytics models, what's analytics, what's big data, we'll come to it. But what I wanted to give you a picture is that this is another breakdown of industry versions in terms of how analytics, in context of analytics, okay? When you look at the industry versions using the lens of big data analytics. This is how the story was. This is how the story picture is. You started from no data analytics in industry 1.0, documentation in 2.0, hard disk storage in 3.0, and ultimately big data started in industry 4.0. This is how the idea is. Okay, now industry 4.0, we use a concept called smart industry. Okay, so smart industry is the hottest and the very, how do I put it? It's a very hottest and very innovative concept these days, smart industry, and a lot of industries are trying to go on this model. This is a very great intersection of technology and mechanical engineering and your manufacturing industry, if you want to. This is where people like us, the AI specialists, analytics specialists, and mechanical engineering people, industry people, they can come together and they come together actually and work on this. This is called smart industry. What is smart industry? Smart industry is basically a very effective and high usage of technology in industrial problems. So you start with the user interface. You got a machine, which on the left you can see a user interface. You got a machine which is operated by a human per channel. You can just give it some input, and it's industry 4.0. As you can see, the 4.0 is written there. So you started with the user interface. It's a very touchscreen interface. You type it out. You press your commands, your instructions, all your machines, your windmills, your machines start playing. At the same time, the data is getting fed in the computer. Your transports are happening via machines itself, and then your industry is connected. You see a Wi-Fi signal in the middle. That means all your machines are connected to each other. So there is a use of IoT as well. And obviously the robotics automation is also there on the top, if you see. And then you as well in the right. So big data, your all your data that is coming from these machines, that is getting stored in big data. And when you are analyzing analyzing this data, making decisions with this data, humans are used at the end. They are actually interacting with the machines and give it instructions, reading the analytics, etc., etc. So smart industry is the most effective use of industry 4.0, is the most effective use of technology in manufacturing industry. You can do pretty much everything in this using all the concepts. You are using automation, you are using AI, you are using robotics, you are using big data, you are using user interfaces, you are using IoT, you are using internet and whatnot. There's so many things that smart industries are covering. So we as analytics specialists, we as AI specialists, we are trying to go towards smart industry these days. We are helping clients doing that. You can also do it. How do we do it? We'll come to it later. Let's get started with the meat of the session. What is big data? Okay, I think this term a lot these days, big data and everything, right? So people have been mentioning about big data and stuff like big data analytics, big data certifications are happening. People are learning big data. Big data is everywhere, right? What is big data? Let's try to boil that down into few bullet points, and then we'll come to it. What exactly does that mean, etc., etc. So big data is about structured versus unstructured data, right? Big data can have both types of data, structured and unstructured. When I say structured, it means it's in a proper form of a table. You can literally see data and tables are there. Unstructured is not very structured, it's not very aligned properly, it's not very organized properly. It's still data, but you cannot see inside a table, you don't see a table. Big data has the power to store both structured and unstructured data. Structure could mean like your Excel sheet, that's a very structured data. Unstructured could be any data, right? Your Facebook data, right? Your the way you are doing things on Facebook, your interactions with Facebook, your friend list example, your list of the friends, your photos, these are all unstructured data. Then you cannot store that in you cannot store that in form of a table, right? It's an unstructured data. So that's the idea of structured versus unstructured. Big data is about volumes of data. Volume is enormous in big data. It's like 100,000 terabytes. It can go even beyond that. So that's the intensity, that's the scale big data works. You can work in millions of terabytes, thousands of terabytes, and big data, the concept of big data would still work. And there are three V's of big data: volume, variety, velocity. Sorry. So there are three V's. It's called V3 of big data. These are the three pillars of big data. Without these three, big data uh, won't be in picture. Okay, won't be in existence without these three characteristics of big data. Okay. And then obviously, I have been speaking about big data where there is no single and clear definition of big data. There are multiple ways to explain it, but ultimately it all comes down to these three bullet points that I just discussed right now. Okay. So big data is important. Why it's very important in industry is that big data, your industry is producing a lot of data all the time, right? Your machines, your robots, your automations, they are producing so much amount of data every minute, every second that you need to have a very great amount of concept which can process this much amount of data. Your millions of terabytes of data, thousands of terabytes of data. You need insane amount of compute and some good storage, some good power processing power, which could consume this particular amount of data that your machine is giving you all the time. Okay, so it's very important to have a concept like this. So let me discuss about the three V3s, right? The volume, variety, velocity. Let me actually elaborate some more on this and let's see how it goes. The volume, okay. A typical PC usually have 10 gigabytes of data in 2000, that's in the year 2000. But now today, Facebook ingest 500 terabytes of new data every day. That's like Facebook's scale right now. 500 terabytes new data every day. Every day. Now, I'm not saying every year or every month, it's every day. Okay. Imagine having a storage system that is used, they are using, which is consuming 500 terabytes of data every day, increasing in time. It's always increasing linearly in time. That's insane amount of data, right? Boeing 737, your aeroplanes also generate data. I took this example because again, I want to connect with the mechanical engineering industry. Boeing 737 will generate 240 terabytes of flight data during a single flight across the US. Imagine a single flight generates 240 terabytes of data, guys. That's amazing, right? That's just, and imagine there are like so many flights at any given point of time. There are thousands of flights in the sky every time, right? Thousands of flights at any given point of time. And if a single flight is generating with 240 terabytes of data, imagine the volume we'll be needing to use to analyze these flights, to use these flights, to store this data, right? It's crazy, right? It's a lot. The velocity now, that was the volume, guys. So imagine if this is the volume we are right now and we are going towards. Imagine what's going to happen in near future when Facebook will have more users. There will be more flights. The flights will generate more data. The data is going to increase many folds, right? Let's talk about velocity, right? We talk about the volume. Let's talk about velocity. Velocity, what do I mean by velocity? Velocity is obviously displacement over time, but that's not what I meant. The velocity is the stream, the speed of the data which the data is coming to me. Data is coming in insane speeds to me. Okay, so click stream, right? So if you all of we all of us are on Facebook, right? There is no chance that we are not on Facebook or Instagram. That's a very rare chance. The velocity is what I say when I say velocity. The speed at that this data is coming to me is very crazy, right? The click streams, when you go to Facebook, you see there's a ticker going on, there's a stream going on, there's a timeline, there's a feed. It's going very fast. The click is happening, the ad impressions are happening. So millions of users are clicking on your ads at every point of time, every second. People are logging in, people are logging out, people are watching images, people are watching videos. Insane amount of data, right? Then there is stock trading, right? You know, stock market, right? It's so fast, it's so high velocity, right? It's just going so fast, right? Millions of stock are coming in microseconds, millions of stock are getting sold in microseconds. High frequency stock trading is happening, right? So many people are using so many stocks, and people are just investing so much in microseconds, insane amount of velocity, right? The speed at this data is coming is insane, right? Click streams happening in every second. Now, microsecond devices are also so click streams are events per second. High frequency stock taking are happening in microseconds. Within a less than of a second, 1/10 of a second, I've already invested $1 million, already make some money, and thus I went out. Machine to machine process data, IoT basically. IoT machines, now machines are interacting with each other and they are exchanging data between billions of devices. That's another very high speed device, right? You can just use it in the internet speeds are gigabytes per second these days. So machines are interacting via internet to each other and then they can just exchange data between each other, right? And that's just a crazy amount, right? And then obviously infrastructure and sensors generate a massive data log in real time. When I say infrastructure and sensors, again, the fourth example is about the mechanical industry. Your mechanical machines, right? Your robots, your automating machines, your supply line, your production line. The machines generate a lot of data actually. That's what I call it by infrastructure. And sensors, when I say sensors, the mechanical engineering industry use a lot of sensors, right? You have what power sensor, you got heat sensor, you got water sensor, you got fire sensor. These sensors actually generate a lot of data in their own time, right? And you got your machines, your machines have so many sensors, right? That too generates a lot of data in real time. So what I'm saying is that it's the speed with which data is coming is getting faster and faster and faster in real time. And you and I cannot do anything about it. These machines are getting bigger and bigger. Your flights are getting more and more. Your your speed of internet is getting faster and faster. So the data is coming in high velocities, guys. That's no doubt about it, right? So data is coming in very high speed. So it's very important to understand the velocity part of data. The variety. Okay, let's talk about the variety now. Variety, when I say variety, obviously variety means the change, the variety, literally that means variety. So big data is just not numbers, okay, dates and string. Big data is also other types of data. As I'm saying, right, it could be geospatial data, it could be 3D data. When I say geospatial data is nothing but your GPS data, right? Your Google Maps data. That's not numbers, right? It could be coordinates, it could be directions, it could be anything. 3D data, your images, your audio files, your video files, your unstructured data, social media data. Big data has the capability to use all sort of data. It's not just about numbers and strings. It can use all sort of data. Traditional database systems were designed to address smaller volumes of structured data, but big data is used, we can actually, it's traditional systems were only on structured data, they were only based on simple structured data. Big data is a different story altogether. Big data can take different types of data. It can just, consume all sorts of data you want it to consume. Big data is a different story altogether, guys. So it's very important to understand that big data. So now we've learned about the volume. The volume is insane. We are getting hundreds, thousands of GB of data, terabytes of data every day from Facebook, from flight. the velocity, we know how speedy data is, how fast data is coming to me. It's so faster that it's getting at great speeds. And then obviously the variety, as I said, the variety is what we are discussing right now. The data is in so many shapes and forms. It could be images, videos, log files, social media, and whatnot. Okay, those were the V3s of data. So next time anyone talks to you, asks you about big data, these are the first three things you need to tell them that, okay, hey, big data is about three V's: velocity, variety, and volume. So always talk about this first. This is how we start talking about big data. Okay. But how did it all start actually? That's the first thing to understand. This was the concept of big data and the related concepts actually was started initially by Google. They released three academic papers. So Google, right? It's world's greatest company in terms of technology, right? They are crazy. I mean, the systems they are using, the how do I say it? The data they are getting is crazy. Google has so much data about you, right? Google has all the data that you can possibly imagine. Google has your social media data, your search data, your Gmail data. Google has so much data. So obviously they need some technology for their massive data processing, right? So their research team developed three major concepts: the Google file storage, which is basically their intelligent storage for storing all the web content. When I say web content, your search, your history, search engine results, search results. When you click on Google, you search something. All those results that come, that getting showed to you, they are stored somewhere. They are stored in Google file system. Then there's a concept called MapReduce, which is basically an algorithm of efficiently processing your data by distributing it among multiple computers. That's called MapReduce. That's what used by that's the MapReduce is the concept behind Google's so fast page loading. Right, the moment you type anything on Google, it's coming so fast. How they use MapReduce and web page rank and all those things. So there's something called page rank and web search index, but all of that works because of MapReduce. It's very fast because of the MapReduce. Then there is Bigtable. Bigtable is basically Google's data analytics storage, data analytics database where you can store your data and do analytics with it. So that's Bigtable. These three research papers came in 2003, 4, and 5, and this is where the whole picture started. Okay, this is where the whole game started. Let's move on. So now we know that Google actually released these three papers, right? So the world knows Google's concepts of processing so much data, right? The world knows about that now. What happened after it? How did these three papers become big data and what we see right now? So what happens is that in 2004-5 time, a concept called Hadoop comes up. What is Hadoop? So there was an engineer like me called Doug Cutting who actually was using a lot of data, and he was struggling that he actually developed a web search engine called Nutch, which is basically a free version of open source version of Google. We called it Nutch. And he again, since he developed the search engine, he's struggling with the data processing issues. He was struggling with that he was getting so much data, but how do I use this data? So Doug implemented a file system called Hadoop. Okay, so Hadoop is basically again using the concept of MapReduce and all this concept I was discussing in the last slide. Doug Cutting actually used those concepts and developed something called Hadoop. Hadoop is basically a system, a concept which can consume a lot of heavy files, and it's open source and it's free. All of us use Hadoop in big data. That happened in 2006. You can see the fourth point is left blank. The fourth bullet is left blank. That's intentionally left blank because after 2006, the scope has been enormous. There has been such a great amount of growth and development that happened in this space. That fourth point has to be left blank because we are still doing so much that we are still going beyond and beyond in this area. So I'm not there is not a single point that can cover all the development. There's so much happening in it right now, but this is where we are right now. Okay, that was the idea of what is the concept of big data and Hadoop, guys. So these are the pillars, the foundations of using Hadoop and big data. Let's actually start about talking about big data challenges and analytics, and how exactly big data helps you and me in mechanical industry. Okay, so I need to have some water. All right. The big data challenges, right? So let's talk about the actual data, right? Now we have so much big data, right? So in the top bar graph, bar chart, you see structured and unstructured. So you can see uh, unstructured start at the top. So you can see a lot of data is structured. We see most of the data is structured, right? The complexity is orange in orange. So you can see the complexity is increasing. And the more data gets unstructured, if you see in the bigger bar in the middle, the more complexity increases, the more unstructured the data is. That's the simple rule. Can you see the industry is divided into different sorts of data. If you can see in the second bar chart, you can see the second histogram. Archives mean the historical data, data from 80s and 90s from the machines. Docs means your documents, your PDFs, your Excel sheets, your normal docs, Word doc. Business apps, obviously, when I say business apps, I mean the visualization apps, your all those business data visual business analytics apps, your visualizations apps. Media, when I say media, it could mean a lot of things. It could mean your video, your normal media. They want multiple media to communicate, right? The video calls, the audio calls, etc., etc. Social network data is there for industry. Obviously, Facebook, Google, Instagram, LinkedIn, etc., etc. Public web is your actual search engine stuff where all the data is in public or internet. Everyone is using it. Data storage is right. So you got like data storage data, your storage data that's already your company data that's already storage in data. Okay. And then machine log data, which is basically your machines my mechanical machines, my actual robotic arms, they are generating a lot of data. Sensors, my factory has a lot of sensors, so they're generating a lot of data. So if I have to explain that, you can see in the bottom archives are scanned documents, medical records, previous. Just a minute, guys. I just need some. I heard some voice. Just give me a minute. I'll be back. Just a minute. I'll be back in a second. Sorry about that, guys. I just had. Can you guys hear me? Can you guys hear me?
Yes, sir.
Awesome.
Yes,
Okay.
sir.
Thank you guys for bearing with me. I had some noise. I just had to take care of that. All right, I'm back now. Okay. Let me know when you can start seeing my screen. Can you see my screen?
Yes, sir.
Awesome. So big data challenges, right? As I said that your data is so much in form. You got docs data, which is your PDF, CSV, HTML, your business apps, your EIP systems, ERP systems, CRM data. CRM is customer relationship management. When a customer care executive calls you, they are actually recording your journey from the time that you were able to talk with them. So CRM is customer relationship management. So from the time a customer is onboarded until the time they are in the system, we actually record all of that. That's CRM. Media, I said, images, video, audio, etc. That's media, social networks, public web, Wikipedia, news, all the public sources of data, data sources, machine log data, sensor data. These are types of data you can have. So you can see big data has got the volume, that our data is enormous in form, and in dark blue you can see, if you see, right, so the v3s are there, the velocity, variety, and volume. You can see in dark blue is velocity, in sky blue is variety, and light blue is volume, right? So sensor data has got all three of them. Sensor data is highly complex, right? Because they have got all these things, right? They got high complexity, they got volume, variety, velocity. Machine log data is also like that. So as mechanical engineers, the main Interest area lies in the last two columns, machine log data and sensor log data, and these are the very complex ones, right? You can see the three. These three are very complex. Other ones we don't use that much in industry. These two we use that mostly, and these are the ones they are very complex, right? So that's what we'll be focusing on. Let's talk about big data and industry 4.0, right? So big data and industry 4.0, how exactly industries are using big data in 4.0. Now we know what is big data. We know the history behind it. We know the industry, the data that industry can have, that kind of data industry can have, how exactly happens. So analytics is basically nothing but analyzing your data, right, in multiple forms and shapes. Analytics is that, right? The name suggests you're analyzing something. What do I analyze? Sensor data, right? Your factory's got a lot of sensor data, right? Your machines are working, your sensors are working. Sensors are throwing millions of bytes of data every minute. Your light sensor, your heat sensor, your machine sensors. There are so many sensors on a single machine. It's giving me so much of the data, right? Then your factory data, yeah, now that your sensors are throwing so much data, your factories are also factory. When I say factory, I mean your robotic arms, your supply chain, your production line. All these machines are showing so much data as well, right? And then this is creating a value chain. What is the value chain? Basically, this is all the data is coming together, and you're getting a constant data flow. I mean, this whole chain of your factory working, right from getting the raw material till the point your end product is getting shipped. It's a value chain. So sensors is throwing some data, factory is working, your machines are throwing some data, then the value chain and constant data flow is happening. This is how the analytics happens in industry, guys. So constant data flow is coming from these sources. We collect this data, analyze this data, visualize this data, draw graphs with this data. We detect patterns. We analyze that, what, hey, there's a pattern. This sensor is throwing a lot of issue. There's something wrong with this sensor. All right. So the production last year was 500 units. If you do this, it could be 1,000 units. In next quarter, it could be 2,000 units. That's the prediction from your data. Your machine is not working well, this machine is working well, this machine can be better. So all these questions we can answer only when we use this data. So all this answer that we answer to business people is using this data. We can collect this data from machines and we can answer enormous amount of questions, right? So that's what's happening. If you see in the left of this slide, right, I'm in the last bottom arrow. We are learning, optimizing, and monitoring, and new business models, right? So we are learning at the same time, learning how my machine is doing, how my industry is doing, optimizing it. That hey, you know what? If I use this machine in place of that, I could maybe make 400 units more. If I maybe use this power setting and use this machine, use this sensor. If I look at the data, I can optimize that. I can monitor this. I can monitor also, right? Okay, all my machines are going good. I am seeing live graphs. Everything is going good. The moment the graph goes down, hey, something is wrong with that machine. New business models. So now that you know what's happening in your business via data, you can use new business models. You can think, okay, you know what? Next month my sales are not looking good. Maybe I could stop producing less machines now. Okay, next month the demand could be more. I should produce more machines now. All these things are happening using big data, guys. Industry is using big data for all this, which is great, right? All these things are happening in real time right now. What is big data analytics now? Okay, now we know what is like how industry is happening, but what is big data analytics, right? So there are two things. There was traditional analytics, which is called BI, which was the older times, which were basically the times when only the reports were made, right? Only descriptions like descriptive analytics was used. I mean, when I say descriptive analytics, it was just using basics, right? Focus was on descriptive analytics. When I say descriptive analytics, it means that only graphs were made, plots were made. We were just performing basic diagnostic with the data. That was the older times that I was showing here. It was using in older times. That was big data, traditional analytics. Okay, data sets were limited. Data sets were cleansed, very clean data, and the support was there. What happened and why? So that machine, I'm seeing the machine graph, machine plots, machines predict descriptive analytics, and I can tell, okay, yeah, something has happened and why it happened, and let me check my data. That was traditional analytics. What is big data analytics now? Just a minute, I just need. Thank you. What is big data analytics? So big data analytics is now that we've got so much data, now we have the now we have Hadoop, now we have the possibility to use that much amount of data. Now the big data comes up. Now the volume of data is crazy, right? Now we have so much amount of data. I can now focus on predictive analytics. I can make predictions via data. Now that's, as I said, AI usually needs a lot of data to work on, and big data is the engine that's providing you a lot of data, right? So now I have a lot of data, right? So now I can do predictive analytics. I can predict things in future. I can predict the demand. I can predict the supply. I can predict the sales of next month. That's big data analytics. Now the data is more, you can do predictions with it. You can do data science with it. You can write AI models to work on your data. You can write predictive models to work on your daily models for analytics, right? Data sets. Data sets are obviously now more in big data analytics. The data sets are more now, more types of data. As I said, you have got, if you see this slide, you got so many amount of data, so much amount of variety of data, right? Big data is made, it's defined by its variety. So more types of data. Raw data is there. It's not just the structured data, simple data. It's very complex social media data, and your so much unstructured data is there. Complex data models. Now the data is complex. The data models will be complex too, right? So big data analytics is very, very new and interesting and very complex and very, very what do I say? Technically advanced way of doing things. That's big data analytics, guys. Okay. That was the idea of big data analytics. Let me take a pause here and I'll take 2, 3 questions right now if we have any, and then I'll move to the later to the session. Okay. Let's see if we have few questions. Prashant, do we have any questions, sir? Okay, no worries, no worries. All right, then I'll move on. Let's move on. Okay. Now let's talk about. So now we know what is big data analytics, right? So we know what's big data analytics, and that is pretty clear now. But now the question is how exactly that happens in manufacturing industry, right? This is what we are all interested in, right? This is the example of how it happens in industry. So this slide is telling you that only. That let's say you have some machines, right? So you got machines with you, like your actual mechanical engine machines you can see, right? There are a lot of workshop machines I can see in this picture. All of them get streamed into a data cluster. What's a data cluster? Which is a storage where all your your big data storage, your big data cluster, where all your machine storage is, your storage is happening. All the data is coming to this particular cluster. Okay, your data is getting streamed. All the data is getting streamed in this particular cluster. Okay, and then this data cluster, which what you see right now is where the data is getting stored. Now you can do real-time machine learning, which is basically you can do real-time analytics. Machine learning is real-time predictions, obviously, real-time analytics and data storage, obviously. So when I say real-time machine learning, you are able to predict stuff because of that, my machine is working good. It's producing 500 images this to currently. Next month I can produce maybe 1,000 images with this particular machine. Machine learning can give you predictions on that. I can give this much amount of sales with this machine. Machine learning gives you that. Okay. That's the idea of machine learning. Like that's the real time. So you can see just using big data, what all you can do. You can do real time analytics. When I say real time analytics means your real time in the real time, you can see your alerts that, hey, okay, I got like 100 machines working on my floor right now, and I'm getting the data from all of them. I can see the plots real time, the analytics, the graphs are there. Okay, this machine has got a good graph. Okay, the graph is going down. Something's wrong with this machine. Hey, you know what? Stop that machine. I don't want to use that machine. Something is wrong. The computer is telling me something is wrong in this machine. That's real-time analytics. I could say, okay, these machines are not interacting. This machine is stopped. There is no data coming for that. Okay, this machine is stopped. All right, go check what's happening in that machine. Real-time analytics. Amazing, right? Your machine is working so much and you are sitting in your AC room. You are not going to the workshop and you are sitting in your AC room with your laptop. In the real time, you are seeing everything. Hey, you know what? This is not good. This is good. This is awesome. Real-time analytics. Data storage. Now we got so much data coming from so many machines, right? you're getting live analytics, you get real-time analytics. Now there's something called 360 analytics as well. So this real-time analytics, which I was giving an example, you are monitoring. You can also see the historical data, right? Your machine are throwing so much data, right? The machines are throwing so much data, right? That's coming in picture so much, right? You can see analytics 360 degree of production, right? So what's happening in production? You know what's happening is how overall my industry what is doing. I can see take all the historical data of few days, of few months, and get a very 360-degree view of what's happening. Okay, in last 1 month, 15 machines failed, 85 worked. This is the common faults that happen. This is the average efficiency of each machine. Overall, my industry is producing this much. If I improve these machines, I can. This is called 360 degree view. You can basically view all about your production and manufacturing easily using the historical, and that's using the historical data storage. You can see a simple concept of big data is able to help you so much. What's the output? Obviously, if the prediction is if I'm using machine learning, the prediction is happening. I'm getting the predictive material planning, right? I know that okay, next month my machine is going to I will have a demand of 1,000 units. I can plan my material accordingly. I can tell, you know what, I need maybe better materials now. Okay, I need maybe more material now to produce more demand next month, more units next month. Quality management, right? You can manage your quality, that you know what, this machine is failing 10 units this month. With this speed, in next 1 month it can fail 30 units as well. So I need to have a better quality management. I need to predict my quality. Then there is production line maintenance, right? In the live, when you are doing the real-time analytics, your production line maintenance is happening live, right? You can see your production line is happening. Quality assurance, you can see production quality assurance is happening live. You can see your quality, your production. You can live in the real time. You can see the quality of the production, etc., etc. Right? Amazing, right? Simple big data is helping so much in mechanical industry, in your manufacturing industry. Awesome. Now the question is, how do I apply it to my business? I already talked how it works, but there are a few steps we need to follow, right? There are a few, uh, how do I put it? There are a few things we need to follow when I say how can I apply big data analytics to my business. Define the problem well. First of all, define your data well. If I come to you, I as an analytic expert come to you and you ask me, you know what, Umang, I want to do big data analytics in this. How can I do it? The first question I ask you is that, you know what, why don't you tell me your business properly first? How exactly does your business works? How does exactly all your machines work? I mean, what is the job of which machine? What kind of data they are producing, etc., etc. So I need to understand their business problem well first. Then only I can talk about using big data analytics in my business. Okay, define the problem well, very very well. That's the first question. If the problem is not defined, if the expert, your analytics expert, is not clear of what's happening in your business, if that is not well defined, nothing is going to happen. Your whole system will fail. Secondly, understand every business has some problems which could be solved via big data analytics. Yes, every business has some problems. There is a potential in every potential business. There is a possibility of using big data analytics, and there is no doubt about it. Okay, that's very much possible. Start with answering the few basic questions, guys. When I say few basic questions, again, it goes with the problem that, hey, you know what? Do I have enough data? Do I have enough resources? Do I have enough money to spend on setting up the analytics in my industry? You know, the machines are there, data is coming, but do I have the infrastructure? What all is required? What are the resources would be required? What kind of computers would I need, etc., etc. And as I said, possibilities are endless. Possibilities are indeed endless. You can do so much with big data analytics that's the possibilities are enormous. You can, as I said, you can analyze. That's just the tip of the iceberg. You can scratch more. You can do more. People are doing big data analytics for so many things. It's just amazing, guys. Now let's again elaboration of the last slide. What's the problem? Again, let me give you a pictorial view of how I can do big data analytics in my business, the process of using big data anywhere. First step is obviously identifying the problem. Hey, you know what? What's the data problem? What's the problem do you want to solve? Do you want to do the real-time monitoring? Do you want to do predictive analytics? Do you want to do machine learning? Do you want to do the 360-degree view? Do you want to do all of it? Define that well. Secondly, design data requirement. You know what all data do I need? If I want to do real-time monitoring, what all data do I need? Design the data requirement. So we basically note down all the sources of data and then design these requirements. Okay, what this is the kind of data we have. This is what we can do with it. This is what we get. Then third is pre-processing the data. So obviously raw data cannot be used in its form. So we write some logic to process the data, clean some data, remove some bad data. That happens a lot. At times what happens is that due to some machine errors, bad data also comes in picture, right? For example, there is a machine, there's a sensor which is giving me temperatures, right? In Celsius, okay? And we know that, Celsius in temperature Celsius, and I know that in a factory setting, temperature cannot go beyond 100 degrees. I mean that's also too much. It max it can go 50 degrees, right? That's the maximum a factory can get heat up, right? But let's say our sensor misfunctioned, the sensor had some issue, and it gave me 1000 degrees Celsius as the data point. That's wrong, right? So I need to write some logic to check and capture this kind of issues in data easily. Then only I can just, then only I proceed with the step 4 of it. So step 3 is very important. It's called the pre-processing the data. You need to make sure your data is clean and everything is correct with it. Then performing analytics over data, which is fourth point. That obviously that's the end goal, that I can analyze my data, I can do real-time analytics with my data. And then the fifth point, obviously visualizing the data. I can draw some plots, I can do many stuff with it. And whatever I do at the end is up to me. But these 3-4 steps are very important before I reach there. Okay. That's the process of big data analytics, guys. And this is how we, do big data analytics in any typical form. Okay, that's the basic idea of big data analytics, and in its very very high level form. The use case of big data analytics, right? As I said, there are three major ones: real time intelligence. Then these are the people like who real time intelligence is basically live people who are live real time analytics. That hey, how the machine is happening. These are the consumers. When I say consumers, the people, right, who are actually using your machines, right? Who are people who are working on machines. So these people require low latency. When I say low latency, it means the data should vary. The different latency is basically the time taken between the actual data generated, and when I can see it on the screen. It should be very small, right? The time when the machine generates the data and the time when it comes to screen, it should be as small as possible, right? It should be microseconds, right? If there's a delay in that, and that makes no sense, right? The machine is already failed, and my computer is telling me that after a minute or 2 minutes that your machine is failed, which makes no sense, right? I by 2 minutes I already lost so much money. My failed machine already stopped my production line, and all the bad things have already happened. Maybe a fire has already taken place, right? That kind of stuff can happen, right? So that's the issue. So it's better that they should be low latency. That's very important for real-time intelligence. Then there is value per business reporting. The business users, right? Your business people, MDs and VPs and all those people, they need to see the reports that okay, last month how much how did my factory did, how my machines did, how did everything happen last month. Data discovery. Then people like data scientists like me who can just come up and say, using all the data that machines have produced, historical data, we can do data discovery. We can we can find patterns in the data. We can analyze the data. We can write algorithms on data. We can do predictions on data. So these are the three major use cases that can happen in big data and the big data analytics use cases. Let me give you an example. Okay, data discovery. Data discovery is what people like. The third part of it, right? The value performance, the data discovery. How do we do it? So on the on the left, you see structured data sources, right? Structured data sources. When I say structured, semi-structured, unstructured, there are multiple data sources. Structured data sources could be your machine data, uh, and machine can also have semi-structured data. Your sensors can store semi-structured data, unstructured data, right? So semi-structured data is there, which is nothing but your, let me give you an example actually. Let me give you an example. Semi-structured data is again data from coming from sensors. your machines, your production line data. Unstructured is totally unstructured data. How your your users are interacting with the machine, that kind of data. That's the first layer. It's called, let's call them layers. Okay, we call them layers. Data sources, I told you, right? What data sources? There are multiple data sources. Then there is integration, which is basically, there is a lot of IT terms in this. Don't get overwhelmed with the IT terms. I'll explain all of them in a very, very easy format. So integration is your what is integration? Okay, so integration is nothing but your tools, which the whole job is to take the raw data and integrate with your system. So take it to your storage. So ETL is basically extract, transform, load tools. These tools take your raw data, do some transformations, remove the bad data, process it, put it into your data storage. Messaging, obviously, if the data is coming in very, very fast formats, right? Data is coming like 1, 2, 3, like very, very sensor data, like sensor data, IoT data. These are coming in very fast formats. And there is no single source of data, right? 100 machines, 100 IoT devices throwing it at the same time. This is called messaging data, guys. In tech, in IT terms, it's called messaging data. Hundreds of IoT devices throwing data in the same time. Okay, 1, 2, 3, 4, 5. Like so much data is coming from all directions. This is called messaging data. So we have algorithms, we have services, machines, we have software taking care of that data as well. Then there is API data, ODBC data. What is API, ODBC? Which is like they are simple data. They are reading data from sources. The application is like we make the copies of these data to store as well. That's the integration layer, guys. The integration is layer is basically when data is coming and we are integrating the data with we are integrating that data. We are combining the kind of data. We are combining this data. That's integration layer. Then there is data source storages, right? So now I've processed my data, I've done my data processing. I store this data in data warehouse, data marts, with a pretty similar stuff. There is hardly any difference between these data warehouses, data marts, operational data stores. These are three concepts, but these are pretty, as a mechanical engineer, these don't really they make a difference to you. Let's call them data storages, okay? And obviously, I have the data. I can do analytics over it. I can query. Query means you are literally questioning the data. Okay, you know what? Give me the data of last few months. It will give you. Then there is OLAP cubes. OLAP cube. Okay, let's not go there. OLAP cubes. Oh, let's put it that way. OLAP cubes is nothing but your structured data, your tables of data. And then you can do advanced analytics, which is nothing but your machine learning predictions and etc. etc. Then there is the presentation layer. Now you got your query, your data and reporting and everything, right? Your data, analytic data is ready. Now you can present this data to people. You can present in form of a web application or a website. You can present in form of a native desktop, like a normal application. You can present in a mobile device, like an app. You can present in form of web services, etc. Presentation you can do any way you want. These are the way you can this is an example of data discovery, that the third part of it, data discovery, the people like me and data scientists and analysts do. Okay, all right, now the question is values to industry 4.0. So that's the like, so first of all, we got the data analytics, the data discovery and everything, right? We got the whole idea behind that. Now values to big data, values to industry 4.0, very important. How big data values, how big data gives, how big data helps in industry 4.0, efficient technology. Now that everything is automated, your big data is there and everything, IT costs are down. It will decrease your IT cost, right? Because now machines are automated, machines can read data in automatic fashion, your services are running and etc. So the decrease cost for IT for sure. Linear cost increase. And when I say linear cost increase, that's about your linear increase in linear cost increase means that your big data cost increase linearly. It's not like big data cost can increase exponentially. It can only increase big data cost. It depends on you. It won't really go exponential. It will go only linear, and it would be very small. I mean, it's very simple increase in the cost. It won't be like it's up to you. You want to add more big data. You want to add more machines. You want to add more data. Okay, add some more machines. Add some more software. As simple as that. Small scale POCs, yes. So you can do small scale POCs of big data. That's what people start with. Industry POC means proof of concept. So you can start with a very small scale proof of concept, and It's simple, right? It's not like you have to invest $1 million on the first day itself. You can start with a simple POC, and you can say, okay, yeah, that's going good. Let's go. If that works, let's go above and beyond that. Commodity hardware is basically, let's how do I say? Commodity hardware is that the hardware is nothing but your computers itself. There's like nothing hard and fast about it. You don't really require supercomputers to do big data. You can do with computers. Yes, you need a lot of computers, lot of clusters, but that's easy. You can do that easily. You don't really have to worry about that. You can do it on cloud as well these days. Fast time to market. Yes, so the setup of big data is not very time taking. In a month, I can set up a big data for you. In maybe 2 months, I can set up more big data for you. So it's the technology is pretty efficient of big data. It's very fast, it's very efficient, etc., etc. Data capture and analytics. Yes, as I said, now the technology is very efficient, it's very fast. You can start with the POC, you can start with stuff like that, right? So technology is pretty efficient in big data. When I say decreased cost for IT, when I say the technology is pretty efficient, it's pretty fast. You can start with POCs, you can start with stuff like that. Second pillar of the promise that values the value the industry 4.2 receives from big data is capture analytics, right? Data capture and analytics. Data store in one place. As I said, you can store all your data in one place using big data. It's simple, right? Your big data will store all your machine data, your sensor data, your social media data, etc., in one place. Data is fully accessible. Yes, I can easily access the data. It's very fast. Real-time analytics happening. It's very fast. It's very accessible. Data is fully analyzed. Analyze, I said, analyze the whole data properly. Like you can see the patterns in data. You can see the plots in data. Pattern detection on all data. As I said, you can detect pattern on all kind of data. So that's the idea of data capture analysis, right? That's another value that brings big data brings with it. Okay. New opportunities. Yes, improved manufacturing process. If I'm able to analyze what's happening with my machines, if I'm able to analyze that kind of stuff, what's happening with my machines, and what's happening in my all my machines, I'm getting the real-time data of my machines. I can improve my processes. I can say, okay, if I use this machine for some time and that machine for some time, I can analyze that okay, this machine works better, this machine doesn't work better, this machine can be better, etc., etc. So there is improved manufacturing processes. You can improve the process via big data. Okay. Then there is improved customer service and experience. Yes, because now you can analyze your machines, you can analyze your what's happening in your factory, you can analyze what's happening in your business, in your production line. You can improve customer services. You can tell, okay, you know what? Like an example. Let's say I bought a washing machine recently, and I called the washing machine, and it came faulty. Okay, there was a big issue with the machine. What do? I call the washing machine company. I said, you know what? This is the issue I'm facing with the machine. I need some help there. I need a replacement. So they are like, okay, can you tell me the batch number of the machine, the unique batch number of the machine? Okay, I tell them, yeah, this is the model number, this is the batch number. So they take that all this data for me. Now they can go to their analytics system, enter the batch number, machine number, and they can see that okay, at this time which machine was working, was there an issue with the work machine? Let me see the machine data as well. Okay, this particular machine X was working, and there was an issue with the X machine. That's why my washing machine came as faulty. Improve customer services, right? What an amazing experience, right? I just give them model number, and they analyze everything, and we are good. Cost optimization, as I said, if you can optimize your machines properly, you can decide which machine to use, which not. Cost is optimized, and obviously new services based on data. You can create new services based on data. You can provide new services based on data, etc., etc. That's the value big data comes to brings to industry 4.0. Okay. Now the question is components of big data, guys. This is a little technical part of the IT part of it, but I wanted to give me guys, I wanted to give you a full picture where the processing is hosted, the computers, all these things, the cluster, the machines are hosted. You can either have a distributed server. Basically, you can what a distributed server. That's nothing but you have got like a machine server. You got like 10, 15 CPUs connected together. That's a distributed server or cloud. Usually people do cloud, then people do distributed server as well. That depends on you. Storage you can store in cloud again. Cloud is very helpful these days. Cloud will take care of storage. Programming model, distributed processing, which is basically distributing your workload among all the CPUs. MapReduce does that. Google's MapReduce does that. How data is stored and indexed, high performance in the schema-free database. So data is stored on multiple databases. You can use high performance database like MongoDB, which is very high performance. You can use that. What operations are performed on data? You can do analytics, semantic processing, and etc. etc. So big data analytics, these are the basic components: processing, storage, programming, where it is stored, and then and perform the analytics. Last point is again left. Last bullet is again left empty because you can do much more with big data analytics. So there you can add more steps to it. That's the idea of putting the leaving the last bullet empty. The possibilities are endless. You can add more components to it at the later point of time. Now the question is approaches to learn big data, right? Very important. How do I approach a big data problem, right? So, I mean, an approach to learn big data, right? How you and I can learn big data. So you, for example, can learn big data. So the idea is you start with the basics of big data. When I say basics, you learn what is MapReduce, you know what is Hadoop, you learn what is big table, etc., etc. You learn these basic ideas of concept first. Learn Python. Obviously, Python is the very common language of using big data these days. There is Java and Scala as well, but Python is the common one. Scala you can also, but Python is the more recommendable one. Learn the basics of data engineering. You should learn the data engineering properly. That okay, this is what happening in data engineering. What's the idea of data engineering? And obviously, then you can. The first step would be learning analytics. This is how you should learn. If you want to enter the field of big data analytics, this is how you should. This is the path you should follow. Then there is risk behind big data projects. Very important, right? So big data projects are prone to risks. Not high risk, there is some slight risk for that. Let me cover that. Unorganized siloed data. For most part of the big data, they are stored in isolated silos, a fact that many firms only begin to recognize and understand when they try to use the information. Okay. What happens is that a lot of data is unorganized. When the industries come to me and said, Umang, I want to do analytics, when I see the data, they have very bad data. Data is not organized. They are unnecessary data. This data which has no sense. Data is missing. Data has bad values and whatnot. So we and analysts actually. So we have analyst team members. They spent a lot of time, cleaning significant amount of data, cleaning this data and integrating with other sources. So they spend a lot of time, significant amount of data, cleaning the data, integrating other sources, etc., etc. So these people spend a lot of time cleaning the data. So that's not a risk, but that's an issue that comes up. I wouldn't say it's a risk, but that's the issue that comes up with the big data. The risk could be that if the data is very bad, very unorganized, then it becomes almost impossible to do analytics with it. That's small risk there. Information overload, yes. There are so much data, spreadsheets are there, trends, opportunities are there. There's so much data that it's tough to analyze at times. The information it's overloaded. We are trying to identify patterns and threats and opportunities, and the information is so much that it's overwhelming, right? You cannot literally find patterns with it easily. The information is so much. So information overload is an issue, and the information overload is too much. There's a slight risk of the project failing because the information is too much. We are not able to find patterns in that. And then outdated analytics. As I said, it could be a problem when the data is, how do I put it? When the data is very outdated, right? If industry gives me data of 1990s and 2000s and they tell me, what, help me with analytics, I cannot. The data is so, there is no sense of using, there is no point of doing data analytics on that data because it's outdated. It will only give you, it's lagged behind, far behind. Okay, that's so we covered what is big data, we covered industries, industries versions, we covered what is big data, we covered the V3s of big data, we covered big data analytics, the use cases, how do I do it? We covered risk, we covered the process, etc. etc. That was the end of session from my side, guys. Let's take some questions now. We got questions. Let's see if we got questions. And I'm happy to answer all the questions now. Okay. This is the time for asking questions now, last few minutes. Go on. I think I'll take from the chat right now. Okay. All right. As a mechanical industry engineer, is it mandatory to learn data analytics? No, it's not mandatory, because the issue is that it's not mandatory to learn data analytics. You can say, I don't say it's mandatory. It's good that you learn. It depends on you. It's not mandatory for sure. You can be a mechanical engineer and keep working on your machines and improve the industry processes, improve the machines there. You can work on that. That's not an issue, but it's not mandatory. But it's better that you are able to understand what's happening in analytics side. It's better that you understand what's happening in your machines. You should be able to read those graphs that are happening in real time. So it's important. It's good for you to be able to understand what's happening with the machines in real time, but it's not mandatory. How do we rectify problem occurring in production unit in real time? That's, as I said, right? Your machines are giving you real time data. You have so many machines, right? They are giving you real time data, etc., etc. So to rectify those problems, you see all those plots, and even you can see the graph, and you can see, okay, this is my graph, which is in the normal scenario. The graph is going up. Now suddenly the graph is growing down, or the graph is going a straight line. It means some issue has happened for sure. That's how you rectify that. That's how you identify that. Okay, this is the problem that I just saw the problem. This is the problem I'm seeing right now. But how do I rectify it? That depends on you. You can stop the production line and say, you know what, that machine is faulty. Stop all the lines machines right away. Or you ask them to change the machine type. You ask them to use something else. Take a side route or something. That's how you rectify problem. That depends on how your industry is set up. But you know there's a fault. Now you can do anything about it. All right. Is there any size of data, min or max in big data analytics? Max, no limit. It could be anything. Min, yes, it has to be at least few terabytes of data or few GBs of data. I mean, there's no direct answer. I cannot give you like there has to be 1000 GB. No, it doesn't work that way. But it has to be a good amount of data. Otherwise, it won't make sense. It has to be good amount of data. Otherwise, you cannot do anything about it. How big data helpful for monitoring performance of the machine? As I said, I already explained this: performance, failure, conditioning, monitoring. All this data is getting thrown at you in the real time. You're seeing all your big data real time. Your machine data real time is coming to you on your computer. All the data is coming to you. You can monitor the performance via graphs, real time analytics. Okay. Is this suitable for all industry? Yes, it's suitable for all industry. All the industries use it. Car industries, tractor industry, manufacturing, all type of industry, people can use it. Okay. It makes it how it suit for small business. I won't suggest. So usually big data and analytics, we don't suggest if the business is not is a very small scale business. It doesn't make sense because you don't have enough data first, and secondly, it takes some amount of money as well. The capital is involved. Its capital is involved. So I don't really suggest everyone in a small industry to use high capital. If you don't have high capital, if you don't have high amount of data, you don't suggest using big data. No. Is COVID data kind of big data? Yes, definitely. COVID is hitting so much data, right? Your cases, your death rates, your recurrence, and your number of cases every day, number of cases every month, insane amount of data everyone. Yes, definitely big data. What is current state of big data application in Indian manufacturing industries? How COVID-19 is leveraging it? So as I said, current status again, people are already using big data for Indian industries. Obviously, people are using big data already in industries, in manufacturing industries. They're already using it. How COVID-19 leveraging it? Yes, you can say that. I don't exactly know how manufacturing industries are using it right now, but what I can assume is that they are taking the analytics and actually are able to predict that, okay, in COVID time, this is how the sales of my machine, the sales of my product is going to look like, right? The sales of my machine is going to look like. This is the status of that. So you can predict, you can analyze how your machines are doing. So this is how big data is helping industries right now. With the definition of big data, about industry 3.2. 3.2, I did there was no big data. There was data in industry 3.0. There was data coming from SAP and all those areas, but there was no big data at that time. Big data came after industry 4.0, and it came recently after 2003, 4, and 5. It came after that only. Before that, it wasn't there. How to fire rectify problem arising in production unit in real time. As I said, you are able to monitor it live and remote area of control. The remote control room also has the capability to stop machines. The machines have the internet in them. These days, that's what the idea of smart factory is. I can sit in a room sitting thousands of kilometers from the actual factory. I can analyze the whole machine going on, and I can stop it right away. I can stop that. Okay, uh, I can stop the machine here from my computer itself. It's possible. I have done that kind of stuff. That's easy. Which platform we need to use for real-time data analytics? It depends. So it depends. You can either use cloud for storage and LLM, but usually we have to develop a custom application for that. There are also tools in the market for this. There are some software as well, but it depends on, there are multiple ways. You can develop your own software application. You can develop your own software, or you can directly use a custom application that's already in the market. There are many of them. Every cloud platform has it, so that's there. Yeah. All right, those were the chat questions. Do we have some questions from YouTube or anyone anywhere else, Prashant? Okay, okay, awesome, awesome. Sounds good. Okay. Yeah, I already answered this question about how capital. I told that, right? If the capital is not enough, then there is no point of using big data. You need to have high capital, high amount of data to use big data. Uh, how do how do we go about implementation of industry in a manufacturing unit? I just explained that in a slide, right? That you have to understand your data, your machines are throwing data. In manufacturing, I actually gave an example in manufacturing unit. So that was there. Requirements, obviously, you start with answering the questions like what was the problem, what kind of data do I have, what kind of data sources do I have, and what I can face with the data. So all the requirements that need to be there. How to collect data from traditional machines so that we can analyze data. So traditional machines, you have to add some circuitry to it. You have to add some circuit components which can realize your data. It's not easy, but people do it. In traditional machines, we add some components, we add some circuits that can take data in real time and send the data in real time. So that happens a lot. I mean, you have to make some circuit additions, maybe add some IoT devices to your machines to be able to send data to your servers, and then you can analyze data. Okay, that's how you can collect data from your machine. Okay, do we have more questions? We can take few more questions. Okay, there's a few one question. So while capturing data from machines, we need to decide data has to be collected based on problem. No, startingly when we are starting, yes, definitely. The answer is both yes and no. Yes, you need to be able to decide which data needs to be collected based on the problem. Definitely yes. That you have to make sure that your right data is coming on. At the same time, you also need to collect the other data as well, because you want to do analytics later on as well, not for real time, in general as well. So you have to take both of these things in mind. Is it only machines or the entire system can be updated to 4.2 with analytics, like men, money, and material? Tough question. Yes, it can be. If we do smart factory, yes, it's possible we can do it. But it's tough to answer right now. It depends on how much automation we are able to achieve. It's very much possible, no doubt about it. It's very much possible. Any more? Yes, so if you have a mixture of data, that's where the your big data comes in picture. We actually write logic to separate the data into multiple storage files, multiple tables, and then only we are able to use it. So yes, it's possible to, we separate them using our programming logic. We do that, and we can analyze it. IBM for data science on the cloud platform. Yes, IBM has some cloud platform data science. Not only IBM, a lot of companies have it. So yeah, that's there. That's a lot of these options exist in the industry right now. So I mean, it's all of it. All of them have something that other doesn't have. So yeah, there are a lot of options about it. Yeah, right. That makes sense. Yeah, I see him in the call. Yeah, I see him in the call, but I don't know. Yeah. Thank you, everyone. It was nice to meet you all. Let's meet soon. Bye.